Well, okay, so have you go through all these material? Okay, now the name of this file is called System of Linear Equation. System of Linear Equation, the one that I asked you to prepare for, right? And that was actually the original, the origin of breaking out this new topics in mathematics called Determinant, Introduction to Determinant. So you know that all linear equation in two unknowns can be set in this form, and then those coefficients A, B, C, D, and those constants are E and F, right, are real constants, right? While the variable is only X and Y, which is that. Okay, and after a series of procedures, so that method is called the method of elimination. So the first step is to eliminate X and Y. X here, and then afterward we find Y. Okay, so that was the way you find Y, and after Y, you find X back. Okay, so here are the solutions for this system. So can you see that for this system, for the original system, you see that that is the ED minus EF over AD minus BC. So you can see that as a that is actually the products of those coefficients to make up the solution. So the solution X and Y depends on all those coefficients and constants. Okay? Can you see any particular pattern from here? Any particular pattern? Don't worry, your voice were in, but they will not be recognized. Maybe I won't put it in YouTube, don't worry about it. So what is AD now? You can see the denominator, AD minus BC, right? AD minus BC. So where is AD minus BC in the system? We call it system. AD BC. Can you see that AD BC form a pattern, right? This is AD, right? And this is BC. They form a pattern, a cross pattern. And then the subtraction tax. Sometimes you have to do subtraction. And also, what about AD and BF in X, for example? The numerator in X is ED minus BF. ED, BF. They also form another pattern, right? And also, let's take a look at the solution of Y. The numerator is AF minus C. AF, C, they also form another pattern, another cross pattern. Okay, and that's why mathematicians analyze the system and then finally come up with a new idea. Right, a new idea. Of course, not limited to 2x2 equation. Not limited to 2x2 equation. So you can see that was the way that we can find a general solution for a system of equation in two unknowns. And in my material, I also provide you a system of three. So here are the system of three, and that will be variable or unknown X, Y, and Z, right? And that will be more coefficients and constants here. Altogether, there are 12, from A to I and then J, K, L for the last three constants, right? And if you go through the steps, well, I made for you. First, eliminate two equations to form two unknowns. Eliminate one unknown to form a system of two equations in two unknowns. And then finally come up with answers. Will have huge work. So that's why I don't ask you to do by yourself. Because whenever you make any single mistakes throughout your steps, you may make your final answer wrong. Okay? And that's why I give you this. So here is the system. Okay? So, product of three, right? Of course, there are no reference for you because I've got only one page. So that's why please refer to my material. Okay? Now, let's start. Again, you can see the solution is formed by form X and y and z are formed by the coefficient a to L. But there should be some pattern defining it. So today, my first lesson is to talk about a new idea called determinant. Now, this is actually originate from solving system of equation in circle unknown. Of course, in our syllabus, we will only handle unknowns up to 3. Okay? Okay. For the 2, for the number of unknowns in 2, you have already handled them in junior form, in form 3, simultaneous equation. But we don't offer you any general solution for that. But in M2, we offer general solution, and you can see the general pattern, a general format of the solution. Okay? So that was the determinant general. So first of all, 2 by 2 determinant. Now here, just assuming that you have go through the material. If you haven't, please go through before you come to this page. Okay, so now you have a general system of equation in 2 unknowns. Okay, so that was the one that I gave you. And then that was the solutions I gave you, right? After reading through the material, you know that the solution is coming from that. Okay, so that was the system. And mathematicians study them in a more analytical way, right? So first of all, they look at the denominator of these 2 solutions. And they found that that was AD minus BC. And then mathematicians tried to define this, because that was made by the cross multiplications of those 4 numbers. And that's why they form, just like an absolute value sign, right? But within which there are 4 entries, or we call 4 elements in this determinant. They are called A, B, and C, D, arranged in the same order, right, as what the system made. Okay? And that was AD, right? The first term was AD, and we used positive sign to determine the product of these 2 numbers. And then minus meaning BC, the product of BC will choose negative side of it. So we choose positive on that side and then negative on the other side. Okay? So if we determine, if we define this, then we can find some more interesting thing from the solution. That was what I described. Okay? And now, let's take a look at the numerator of x. And you can see that that was ED minus EF. And when you see that ED, EF, that is actually these 2 terms and these 2 terms, and other quotes. But since we define the going down arrow to be positive and going up arrow to be negative, so we are trying to make EF here, because this is this answer is coming from the solution of x, right? And that's why don't we use EF to replace the original coefficient AC in that way? And that make our ED minus EF, according to my definitions on this little 2 by 2 determinants. This is already the determinant. Okay? So is that clear? So that was another determinant. And then can we say that now x is actually the determinant of a 2 by 2 divided by the determinant of another 2 by 2. Right? Okay? So that was the replacement of coefficients of x. Because we are trying to find x, then we use the right-hand coefficient or constant to replace the coefficients of x. So you may make a guess of what y is now. For y, you see that? The blue color, y. So the numerator is AF minus CD. AF, CD. Can you see that? AF, CD. And AF, CD is similar, right? So, but the way that we can do is similar. We replace the EF, constant values, we replace the BD, the coefficient of y, by E and F. Okay? And we used to have this expressions. So what you know from this moment is that a new symbol, just similar to absolute value, well, we call this determinant. and that determines involving 4 numbers inside. And the actual meaning of this determinant is like an expression, right? Going down positive, going up negative. That is AD minus BC. Okay? And from now on, you know that the answer for X is simply determinant over determinant, right? And Y is an undeterminant over determinant. So we can deal with answers systematically later on. Okay? Right? This is our original purpose of solving equations. And now, take a look at the denominator. And the denominator is actually the denominator. The denominator is actually the original coefficients set determinant. Okay? So that was the way. Okay, and then now see if we are not satisfied. Of course, you know that mathematicians do not satisfy with only 2 by 2. Right? We can they will ask, can we extend to 3 by 3 cases or even more, right? But in M2 we will only study up to 3 by 3. So here is the system. Without printing out the material, I think you have to go through again, right? The material I sent you yesterday, right? And here will be the original equation, coefficient A to I for x, y, z. And on right hand side you have the coefficient, the constant value j, k, l. So here are the answers. Okay. Of course, it's difficult for you to memorize those, right? Although this is in general, but it is not a wise decision to memorize them, right? And that's why we have to think about whether we can think of a systematic way so that we can still find x and y and z, or we are trying to memorize these expressions in an easier way. Okay? Try to see if we can observe any pattern. So if you want to look at, first of all, maybe we can look at A, B, I, B, F, G, C, E, H, G, E, C, and H, F, A, I, D, E. So look, what is the first term? Can you see any pattern? A, E, I, is it? It's again diagonal, right? And then what about B, F, G? So it's a B, F, and then go back to G, right? And then what about the third positive signs, terms? C, D, H. C, and then D, H, right? So it's almost a diagonal, can you see that? It's almost a diagonal, right? But you have to duplicate another set so as to look at the 4 arrows here, right? And on the other hand, you have negative terms. The negative terms come from the first one, GEC, can you see that? And then H, F, A, C, F, H, F, and then A, right? Okay? And then again, the last one is I, B, B. So is that systematic? Is that systematic? So the solution, the denominator of the solution will always be the value, the expressions I told you previously. A combination of these 6 terms altogether, 3 positive terms and 3 negative terms. Okay? And if we define it now, then please look at X to see if there are something similar to a 2 by 2 case. So first term, J, E, I. Remember what we are doing on finding X. We are trying to replace J, K, L. Remember in 2 by 2 case. We are trying to replace this constant right hand side, those terms in the left right hand side. Replace the coefficient of that particular unknown we are trying to find. Oh, right. Don't worry, you are not in the video. Now maybe you can sit here. Okay. No one will know who you are. Don't worry. You are not in the video. Now, so can you see JEI? JEI. Let's take a look at JEI. So remember that JKL. If we do the same thing as what we did in 2 by 2, JKL equals ADG. Am I right? So what is JEI? So here is J. JEI. Is that the same? And take a look at BFL. BF to the right. So BF to the is that arrow? And then CKH. CK is that K? And then H. Right? Right? So they follow. You can see also why that they also follow with the same arrangement, replacing J, K, L with the coefficient Y, or J, K, L with C, F, I. Okay? So here, that was my definition. A new definition should be given to 3 by 3. Okay? Okay? And then this one. I duplicate. And you can see that those positive terms are coming from those bottom arrow. The 3 bottom arrow generated by the first 3 terms. Okay? By the way, you can only get the 3 arrows of the product of 3. Alright? And then the negative side. Same, right? So if we do the same way, we can find a solution by making use of this new definition now. A 3 by 3 determinant. We call this determinant. Because they are trying to provide us the solution, to determine the solution of this system of equations. Okay? And that was a particular rule that was generated by a machine called Cyrus. And that was called the rule of Cyrus. Okay? This is the way how we find the solutions of the 3 by 3. Okay? Do you still remember there are cases in core, a compulsory part, in mathematics compulsory part, that requiring you to find a system to try 3 unknowns in 3 equations? Do you still remember that